Welcome everybody to another edition of the SIBA webinar and symposia series. Today we have a symposium, which means that we have two papers presented by their authors, their respective authors. Today's motto is decentralized trading. I'm sure that most of you in the audience know that this is a very hot research topic, generally speaking, and there's also a hot topic of development. And today we have a specifically nice version of it for you. We have somebody from the practical and development side from Uniswap Labs, Xin Wan, and we have Agostino Capponi, who is going to present a research paper on JITting. So you learn about what just-in-time liquidity is and what it does. Agostino also has his co-author Rujo here, who will be answering questions in the chat. The format is such that Xin will go first. He will speak for somewhere between 30 to 40 minutes. Agostino will follow right after. And once Agostino has concluded his discussion, we're going to open the floor to questions. Now, if you have particular questions, you can put them in the, is it the chat or I forgot, or the Q&A. One of the two will be open for you. And you can put the questions there. I will monitor it. And if I see that the question requires clarification, I will interrupt the authors with their presentation and ask the question. So please feel free to interact here as you can. All right. With that, I'm going to, Q&A, sorry. Fahad just informed me it's the Q&A. All right. With that, let's go right into it. Xin from Uniswap Labs, we're very happy to have you here. And if you could unmute yourself and start your presentation, that would be awesome. Thank you.
Okay, thanks a lot, and thanks everyone for coming. Let me share my slide. Oops, let me just go all the way back to the beginning. You're probably seeing all my slides, but that's maybe intended. I guess first as an intro, my name is Xin. I'm a research scientist at Uniswap Labs, mostly focusing on kind of the economic side of the trading system design. And today the presentation is more about sort of how does Uniswap X work, and less about either theory or empirical evidence on how it has worked so far. So the idea is to talk about how we envisioned it work when we first designed it, and how we actually implemented kind of the idea. Yeah, I guess let's go into it. So yeah, first, what is Uniswap X, or what is Uniswap to begin with? I think just to give a one-sentence summary of Uniswap, it's a smart contract on a blockchain that allows people to permissionlessly provide liquidity and other people to then come trade against that liquidity. And then the way it works is this contract will quote on behalf of people depositing liquidity in the contract. And then whoever is trading against it will just accept the price that's being quoted. So okay, so this is a somewhat marketing slide, but the idea for us to build Uniswap X, which is in addition to Uniswap, is to use this concept in crypto industry we call intents to create a better and more expressive swapping experience. But first, what is that? And a lot of people in the industry have tried to describe it. A lot of words are being thrown around, and it's unclear, what exactly people are talking about. So let me give it a try as well. So this is, I think, the best illustration of real world intent is, you want to go from JFK to IST. But what you're really thinking is just, I want to go to Istanbul instead of I want to, fly from here to here at this place and then connect and do whatever. So when you have the first thought of, I want to go somewhere, there's many different ways you can do. And so you can, do all of these searches or compare it in your head. But the idea is you just want to go there, right? And I think there's a very similar analogy in trading, which is you want to go from token A to token B. And we're saying, okay, let's just like figure out all the searching in the backend and not bother it with either the user or ourselves, because we also don't want to do all the searching. So that's kind of the Google Flights, but for crypto trading. So we want to, the swapper says, I want to swap ETH for Pepe. Okay. This is what happens before Uniswap X. So before we've launched this new trading system, what happens is you as the swapper, you would come to our front end, which connects in the backend to our routing API. Our routing API then goes to search, all the possible routes that you can take, including some of the pools in V2, some of the pools in V3. V3 pools possibly have more liquidity, but slightly more expensive to interact with. And it gives you, the optimal route. But if you look at the history of the distribution of on-chain liquidity, it really changes from time to time. Like at the beginning of the day, there's V1 only, and then there's V2, there's V3. There's all these other competitor dexes, and each one has, hundreds of if not thousands of pools. I think Uniswap V2 has like 100,000 pools or something. And so searching through that and dynamically updates all the map and so on, it's also very complicated. So our interface routes you through Uniswap V2 and V3, but all the other AMMs are being ignored. And then there's the aggregators, 1inch and CowSwap and so on. And so their promise is, okay, let me just like try my best to include all liquidity sources. But then there's things that are potentially not on chain, or the new dexes, Pepe Swap, that's not being discovered quickly enough and therefore not contributing to the liquidity. So there's this like never-ending struggle as an aggregator to keep adding new sources. And I've anecdotally heard many people say that they are hesitant to develop anything that's unlike Uniswap V2 because all these aggregators, when they need to incorporate some new liquidity, if it's Uniswap V2 like, they can just add the pool address and everything will work. But if it's new, they have to write new code. So in a sense, that's also kind of inhibiting DEX innovation in a way. And now if we add Uniswap V4 in the picture, it's going to be a lot more trouble, because each pool in Uniswap V4 will look different. It will have a hook, and the hook can have arbitrary logic. So it's no longer as easy as adding the pool address to your aggregator server. So what do we do with this? And the idea we have is we just outsource it. And so we outsource it to another market where people explicitly compete on sort of the execution quality of your trading intent. So that's kind of the motivating idea behind us building Uniswap X. And then, one thing that we realize is kind of good is if we do it well, then a lot of the MEV comes from either someone being able to front run, back run your transaction, or from like observing your flow and do something somewhere else. I think in this mechanism, not 100%, but a lot of it will actually be internalized because you're no longer kind of the searcher or the MEV operator. They're no longer given the transaction in the mempool and then competing in the gas auction to do whatever they want to it. So in the old world where they're competing in the mempool, their incentive is actually to extract as much as possible, and whoever can extract the most from the trading kind of transaction will likely win the gas auction. Whereas here, whoever is giving the most price improvement to the trader can win the gas auction. That's really the hope of this design. But then, okay, how does this thing work? I've given a lot of motivation, but exactly how does it work? So this is what you see when you come to the Uniswap interface. You have an input token, output token. You put in either the input amount or the output amount, and then we'll calculate in the backend what you get. And then in this like little toggle thing, you also have these settings where you can set how much slippage you tolerate and how long your transaction will last, and so on. So now with Uniswap X, we introduce a new order type where your order is what we call a Dutch order. So it's very similar to a Dutch auction where the price is going to start somewhere. So if you go back here, your order will go into our system as I'm selling 1 ETH for this much USDC. And then after a while, if the order is not filled, we then infer that, okay, maybe that price is too high. We drop it a little bit. So I say, okay, I'm still selling 1 ETH, but I only want 1880 as the output. And then it would keep dropping until it either expires or it's filled by the first filler who say, okay, now it's profitable for me, I'll fill it. So there's 5 parameters to the order here. And we're starting with only the linear decay. So there's a decay start time, there's decay end time, which determines basically how long the decay is. There's a starting and ending amount. So these two let you kind of interpolate the whole decay curve. And the only reason there's an order duration in addition to start and end is we support this flat period in the beginning. And we'll talk about why we needed that. But that's kind of the 5 parameters here specify the entire curve. So it looks like something in this picture. And the flow, maybe I'm getting ahead of myself, but the flow is, now that I think about it, I think my slides can probably be optimized a little better. But the flow of Uniswap X is you coming to Uniswap X. Actually, let me try to see if I can. Okay, let me make a little jump and just talk about how the Uniswap X flow works. So when you come to the interface, you will see something like this. And then you type in your starting token and your ending token, you put in your input amount. At this exact point, when you have inputted 3 out of the 4 fields, obviously these 2 are always required, our backend will start working, right? It will try to find out what is the likely price that you can get filled at. And what's really happening is we're calling some server here. This routing service server then asks 2 different servers. It asks the classic routing service. So this is, what you get before you have Uniswap X. And then it also asks Uniswap X routing service. the classic one goes to the AMMs and say, okay, tell me what the pools, all the pools in Uniswap protocol combined can fill me at. And then on the other hand, the Uniswap X routing service will ask a bunch of fillers in the Uniswap X network. These are either MEV searchers or professional market makers, or basically people interested in providing this service and potentially earn some money. And all of these will kind of return their prices, and we do some comparison inside routing service and say, okay, this order goes to either Uniswap X or Classic, and we store this data somewhere. So after we've done that, we'll return this to you, and you'll say, okay, this is like what I will get as the result of my intent, and we'll tell you that, okay, you've been routed to Uniswap X, and this could be Classic Uniswap as well.
So let me interrupt you there for a moment. I've seen already some questions in the chat, which I will also get to, but I just want to make an observation here, which is, so Uniswap originally was just a simple smart contract with a website interface, right? And so the most of the heavy lifting, in some sense, if you want, was done, by the smart contract, because it was so simple, right? What you're now creating is actually something. If I would be you, I would be deeply concerned about the regulatory implications of this, because you're kind of putting yourself at the interface of an exchange and a brokerage, right? And so because you're taking a lot of functions on by yourself in the background, right? So all of the routing services that you have there seem to be essentially run by Uniswap Labs one way or another. So is that something that you take into account here? Because you're really deeply into the regulated space now.
Right. So I think one thing I'll clarify is, even before Uniswap X, the smart contracts are little circles in these two big boxes, right? So these are the smart contracts of the Uniswap protocol, but on top of it, we have always operated the front end. And the front end always had this routing API, and this is off-chain. So
right, that's correct, yes. But now the front end actually creates, essentially, you're creating new order types. So just right? So I mean, this is something that I'm quite interested in. I think a lot of people are actually quite interested in. So if an exchange develops a new order type that's usually subject to regulatory approval, right? If you as a brokerage have a particular mechanism in mind for payment for order flow or the like that's subject to regulatory approval. Now you're doing something. Now these items that are being sold, we can argue endlessly what they actually are, but fundamentally you have financial instruments. In many countries, they're considered financial instruments one way or another. And you're providing a service around the buying and selling of financial instruments. I don't know. I mean, is that not something that you're concerned about?
I mean, I think it's definitely something that's very on top of our legal team's mind. I think we are definitely operating on the assumption that most of these are commodities, or I don't even know what's the right way to categorize them.
I don't want to put you on the spot here, by the way, just for the record.
Right. And the order type we create is, I guess, new or not new, because all the previous executable Ethereum transactions inherently are, limit orders, because they have a minimum output that they require, and so on and so forth. So we kind of explicitly add some functionality to the callable program, but I don't really see this as a new, like functionally they're the same. And then I guess in terms of us being like what role we're playing, again, I'm not too sure. I think we have been saying that we're doing everything is non-custodial, and so we send out these like messages on behalf of the users, and all the execution and fulfillment and everything is not in our. So like in this entire process, we're not touching anyone's money. And so the people who are touching the money are either Ethereum validators or fillers, right? So like nowhere in the process, right?
Yeah. So and I know so I don't want to hog the conversation, but I have one more question about this because so one thing that the regulatory process tries to do is to make sure, there's usually a common period where different parties can say, we see the following problem, and it's usually some business considerations that are there. Now, what you're doing is by doing it yourself, you're kind of internalizing these discussions. But can you maybe give a little bit of maybe some background on how you actually, you're developing a process, and you're saying, okay, we're doing this and that on how to optimize the flow. Can you give us a little bit of a sense of why you're doing this and where does this come from? Is this because people demand it, or is this because you in your labs, or you're looking at the academic research around this, or is it that, you have actually had these discussions internally about this?
Yeah, I guess I should have included some of these slides, but I think this is one of the biggest reason, or rather, this is the biggest reason that we think this is needed. Is because we thought our routing prior to Uniswap X was inferior in a way that we can never. It's not our strong suit, and we don't think we'll ever will, to be building the best like indexer of all liquidity out there. And even we actually do it, there's significant liquidity outside of the EVM system that we're not capturing. So the real motivation is just to provide best execution to our swappers. That's really the biggest motivation. And I think along with this, we realized that, if we do it certain ways, we can sort of discourage MEV or internalize some of it, and protect our users from sandwich attacks and so on and so forth. But really, providing the best execution possible to our swappers is sort of the motivating force behind this.
Okay. Just because there was a question actually which sort of touched upon this, I'm just going to quickly ask it. It's a question by Maria. And so she basically asked, is the problem of aggregating information purely technological, or are there actually some, so is it because of complexity, or are there also operational inefficiencies and trade-offs? So, is it that if the pools would actually in some form, or their APIs would connect sort of like in a mega structure, would that be better? Or is this actually what you're doing?
Is the question about what is the cost of adding new pools to aggregator?
I think it seems to be what is probably the current cost that is associated with the fragmentation that we observe of liquidity across different pools, right? And is this the reason? I mean, so I think you actually mostly answered it, right? But you're trying to create an aggregation of the fragmented liquidity, right? So
I think searching cost definitely one of them, and searching cost comes down to, you have to be aware that someone is launching a pool. You have to be your server has to be up and running all the time. It needs to compute a bunch of things, and every time someone writes some new code that you can't just like add, then you have to do a bunch of work.
okay. So let me quickly, so William asked a question, and maybe actually relevant here too, because it gives a little bit of flavor of what do you see actually as the main users for this environment? So, what orders go through Uniswap X rather than through the more, standardized masks?
Yeah,
Is
so
that something special?
that is a good question. Let me just go back to this chart we have here. So the question has some complexity in it. What kind of user? There's only actually one type of user, which is user of our interface. And then whether you go into each one of these is decided by the routing service. Now, you have a toggle for you to, like if you click this thing, you can possibly opt out of Uniswap X. So you can say, I do not want that functionality, just send me to the traditional AMM, which we'll do. But otherwise, you are going to be we will sort you into, you'll get better execution here or get better execution here. That being said, the empirical result is bigger orders tend to go to Uniswap X, which I think makes sense because the whole point is to aggregate more liquidity, and those only matter when the order size is larger.
Okay. All right, so I'm going to stop here asking questions, and Olga has a very good question too, and I think we'll have to get back to this at the end. But maybe just carry on with what you wanted to do.
Okay, cool. So yeah, I'm trying to decide if these are worth talking about. Okay, so let me just go back and talk briefly about sort of our mental model of how this thing works. Sorry, I'm jumping back and forth a lot, but imagine you submit an order here to routing service, and we say, okay, you go to Uniswap X. Uniswap X will ask a bunch of fillers and say, give me your quotes. What can you do? One of them will be the highest, and then we say, great, you provided the best quote. You are then sort of the winner of this order. Now go fill it, right? So what we'll do to that order is we'll use the information, or rather the quote of the winner, to parameterize the beginning of the order. So if the winner quoted 1250 here, we'll say, okay, the order starts here. And then there's a small period of time, I think 2 blocks, is when the winner needs to submit and get order like confirmed and settled in an Ethereum block. And this is the time when the winner of the order will have some advantage in filling. So, once we construct the order with this starting price, everyone can still fill. But this price is only available to the winner. Everyone else needs to fill just a touch higher. And that's to, incentivize people to bid the highest price, or maybe not the highest, but as high as they can in the first place. But if somehow the winner did not fill, or they have some internet issue and they didn't send out the order to Ethereum, and we see that the order is not confirmed in 2 blocks, then every block going forward, the price is going to drop a little bit until the end of the order. And this whole process is rather short. It's about 1 minute. I think it's much shorter than in the past. I think every Ethereum like DEX transaction has a default expiration of 30 minutes. So this entire order right now takes 1 minute and 30 seconds. It either fails to be filled, or someone, and this is literally available to anyone in the world, can pick up the order and fill it at the price as of the time they submit to Ethereum. Yeah, so in comparison, this is kind of what the classic swap looks like. There's one price, but really, this price is not guaranteed. Wherever you get filled, as long as it's better than sort of the slippage tolerance you set, anywhere here is fair game. So the incentive is to really fill it here if you can. This is some cute diagram developed by our devs. They were trying to figure out how to get things to fill fast, get things to fill very frequently, but also have price improvement. And they realized, they can't have all three. So that is kind of it. I just kind of want to give this overview of how this thing worked. It's a little bit out of context for now, but I think once the next presentation is out, you'll understand that there's a lot of similarity between Uniswap X and just-in-time liquidity. And the dynamics that's being derived in their just-in-time liquidity model, I think is also something that we are always thinking about, and we're always thinking about how to push the equilibrium to the good state. So with that, I'll hand over to the next presenter.
Okay, well, okay, so there are still some questions that that came up. Maybe we're going to very briefly go to Olga's question, and then we're going to go as in there's two questions. One is very easy to answer, and the other one is maybe takes a little bit of time, and then we're going to go to Agostino because we're only at the 33-minute mark, so we're good for time. So let's start very quickly with the question of just a data question. And so does most of the volume besides Uniswap and V3 have the same structure as Uniswap V2? So I presume, you know, simple constant product market maker, or are there, okay, do you have any sense of the different mechanisms that exist there and how this decentralized flow is split?
So I would say by trading volume, most of it is either on Uniswap V3, Uniswap V2, or Curve. So Curve handles significant amount of stables trading, but Curve itself is just a special case of concentrated liquidity. And otherwise, I'm quite sure 99.9% of other pools are forks of either V2 or V3, mostly V2.
Okay. I think Fahad sent you a message too. Maybe do you want to quickly comment on that one?
Yeah, so the question is whether users other than RFQ winner can fill even in the first few blocks of the Dutch auction. The answer is yes. The caveat is they need, so during the exclusive period, it's not really exclusive. They just need to fill at a price that's delta higher than, and the delta is set by Uniswap Labs. So we set an amount. I actually don't know on top of my head what the delta is, but for example, if the winning bid is 100, they will have to fill at maybe 110 cents or something. Like they can't just pay a higher gas fee or a priority fee and try to get into the block sooner.
Okay. And so then lastly, and this is actually some question that also Agostino will probably address in his talk, is about the nature of the order flow of, in particular, the one which goes through the RFQ system. It has a sense of an internalized order flow, which we see in equity markets. And there we see particularly that kind of internalized order flow is in some form or another uninformed. So it could be retail orders, although you said it was most likely to be the big orders. But you know, the reality is that there's some beneficial order flow and there's unbeneficial order flow. So one of the questions, so Olga's question essentially mentions that, you know, the nature of the order flow and what decision you're taking will affect the cost of liquidity provision in an AMM in particular. So have you thought about that, and what's the bigger view that you take on that?
Yeah, it's something that we we think about on a daily basis. So yes, I think the dynamic is definitely there. There's a selection bias, and we are very much aware of it. I think the main thing that we can do is to shorten the time between when the AMM is quoting and when other sort of off-chain liquidity providers are quoting. So if they're literally quoting at the same time, then yes, I think everyone just kind of needs to compete on sort of their liquidity as of the time. Now, V3 is very, again, compared to off-chain liquidity providers, really unsophisticated. But that's something, you know, we can't really fix in an immutable smart contract. It's already written, and even us, we can't change it. I think in Uniswap V2, the reason why we said each pool can have arbitrary logic is we're hoping that someone can come up with ways to better distinguish order flow from each other. But yes, just to answer the question, we definitely observe some sort of selection bias in the routing part, and we're constantly evaluating what's the impact on liquidity, what's the impact on effective spread that traders are paying. But I think that the good thing we're observing is, because on-chain liquidity is still there's way to go from it being the dominant liquidity source. So we're still seeing considerable aggregation benefit, and larger orders are indeed getting quite some price improvement from these liquidity we're sourcing from off-chain. So I think that's something that's just we're constantly evaluating going forward.
Okay. The last topic that, so there's another comment from Fahad to us here, which nobody can see, but essentially asks if you can clarify how the fillers can use on-chain liquidity from other DEXs. So whether, in some sense that it's actually an integrative solution which allows other DEXs to emerge.
Right. Yeah, so happy to clarify that. Basically, in the design, the quoters or fillers in the Uniswap X system, they're not really constrained in terms of where to source liquidity. So the interesting thing is, like, I think 1inch Labs also wanted to be a filler. And all the fillers, well, not all, but a lot of the fillers on other aggregators want to be fillers. And so their stronghold is maybe not internalizing flow, but to search really quickly on-chain liquidity and so on. And again, going back to the V4 point, I have already know of a few teams whose kind of business proposition is to build a pool that is suitable for Uniswap X fillers to come and source liquidity from them, because then they don't have to worry about building a front end or having business relationship with different aggregators. All they care about is sort of providing sustainable liquidity to Uniswap X fillers, and that's much easier to handle than kind of figure out what's the backend algorithm that these aggregators are using. So I think implicitly we're just trying to encourage on-chain liquidity to be competitive as well, but also trying to stay mindful of our own routing algorithm.
Okay, well, thank you. Thanks so much, Xin. I'm going to hand over now to Agostino. He's going to talk about his work on just-in-time liquidity, which is highly related to the last piece that we have just discussed. So, Agostino, over to you.
Oh, great. Thank you, Andreas. Let me share the slide. Yeah, I think this is a nice continuation of what Xin was talking about. I also have a slide to connect just-in-time liquidity Uniswap X, which I think are two ways of providing just-in-time liquidity. Just one goes on chain, which is the just-in-time liquidity that I'm presenting here, and the one that Xin was presenting was more an off-chain way of providing just-in-time liquidity. So let me also mention that this is joint work with Rijay Jha and Brian Zhu, both graduate students at Columbia, and they are both here as panelists, so they will help me answering questions. So let me go straight ahead into the talk. This is going to be a game theoretical model to understand what are the incentives behind the provision of liquidity, and understanding also whether or not the current system of just-in-time liquidity provision is already effective, or maybe there are improvements that one can make to have sustainable liquidity. Again, I mean, we will be working under decentralized exchange settings, so I would like to just remind most you what is how does an automated market maker works. I'm sure that most of you are already familiar with it, but just to be on the same page, I mean, we want to provide decentralized liquidity, so liquidity into a pool, for example, an Uniswap pool. And the idea is that if you are a market maker or a liquidity provider, you want to deposit tokens into the pool, and you basically receive a share of the pool, which quantifies what is your contribution, and therefore what's the amount of rewards in terms of fee that you're entitled to, which depends exactly on your pool share. So for example, if we have 100 token A and 10 token B, and you want to deposit, you have to deposit according to the rule of the pool. In this case, if like you want to deposit in a way that the ratio remains unchanged, then you want to deposit 10 token A and 1 token B. So that's like the incentive for liquidity providers, as I mentioned, is to gain pool tokens and therefore be entitled to receive fees paid by those who trades. But why would one trade? I mean, people trade because they have needs, like they might have trading needs, or they have allocation reasons, or they might be informed and therefore try to profit of an arbitrage opportunity between a decentralized exchange and a centralized exchange. But every time they trade, they have to pay a fee for the service that they are getting from the liquidity providers. So, for example, if a trader wants to swap token A for token B, then what he will do, he'll have to deposit into the pool 10 token A, and then he will be extracting from the pool 1 token B, precisely because he has to respect the rule of the game, where like the ratio of tokens have to be unaltered before and after the trade. So in addition to depositing 10 token A, he has to also pay a fee, which is proportional to the amount of tokens that he's depositing. So effectively, he's putting into the pool more than 10 token A. 10 token A plus a percentage of this token, which is the fee, the trading fee that is paid, and which is essentially the benefit that the liquidity providers are getting, because the pool is getting in a way larger, because there are more tokens that are being deposited into the pool. The price at which the trade happens is determined by a function which is called automated market maker. So the automated market maker is essentially implementing an invariance function or invariance curve, which is also referred to as the bonding curve. And the idea is that you basically go in a way, you trade in a way that the value of this function remains unchanged before and after the trade. For example, this is the classical Uniswap B2 constant product function. If we have 10 token A and 10 token B in the pool, and you want to swap token B for token A, then what you have to do is basically to make sure that if you put 10 token A, 5 token A into the pool, the amount of token B that you will get is essentially smaller than the 5 token A that you have deposited. So despite the ratio was 1 to 1, now when you take out token B, you take out less than 5 token B, despite the fact that you are depositing 10 token A. And the reason is precisely that you are paying a cost, which is the price impact caused by the trade. So trading is costly, and this cost is reflecting by the convexity of this pricing function. Mathematically, essentially, you can do the calculation, and if the pricing function is A times B, so the product is 10 by 10 before the trade, after the trade, it has to be 100. So that means that if you put 5 token B, then the amount of token, 5 token A, the amount of token B that you take out is 3.33, precisely capturing graphically by the curve that I've shown. Okay, so this is basically all what we already know about decentralized exchange and Uniswap B2. The other point that I want to mention is that the price impact of the trade depends on the convexity of this pricing function. As I've shown before, you don't really, even if the ratio of token A to token B is 1 to 1, when you trade, you don't get really an amount of token which is the same as the one that you are depositing in, but you have to pay a price which is reflected by the convexity of the curve. But the price impact also depends on the depth of the pool. For example, here you can see 2 different levels of depth. The yellow curve corresponds to a deeper pool than the blue curve. And if you have, let's say, 4 token A and 4 token B in the pool, and then you trade, you see that the slippage, the amount of price impact that you pay in the case where you are trading in the deeper pool is lower than the price impact that you are incurring if you are trading in the shallower pool, which corresponds to the bonding curve X times Y equal to 4, right? So that's basically the idea that the deeper pool, the punchline here is that the deeper pool and a more convex pricing function corresponds to lower price impact paid during the trade. Okay, so now before we go to just-in-time liquidity, I want to mention what are the risks of providing liquidity. So one of the risks is precisely the risk that the pool can be arbitraged, in the sense that if one observes that there is a misalignment or a temporary misalignment of prices on the centralized exchange from the prices on the decentralized exchange, then you can trade in suppose that you observe that the price on the centralized exchange of token B has increased by 1 to 2 compared to the numerator price in the centralized exchange. So token B is much more valuable now than token A, it's twice more valuable than token A. So if you are like a sniper or an arbitrager, you can go into the centralized exchange where the ratio is still 1 to 1, and you can swap token B for token A, and you can basically gain a profit, right? Because you have basically you have exchanged a more valuable token for a least valuable token. That's also referred to as the stale price arbitrage. And here I'm saying that this is a pick of risk, because in a way, who is losing from this are the liquidity providers, because they are left out with, let's say, the least valuable tokens in the pool. Okay, so this basically is the cost, one of the main costs of providing liquidity, and one of the main reasons why Uniswap liquidity providers are losing money. So far, I focused the discussion on Uniswap V2. I think the same type of insights apply to Uniswap V3. It's just that instead of like having a pricing liquidity provided throughout the whole interval, you have concentrated liquidity provided around some specific quotes. But the idea is that because of this problem, because of this risk that the liquidity providers can be picked off by these snipers when there are arbitrage opportunities, most of the liquidity providers are basically losing money. And therefore, this is problematic for the entire ecosystem, because if the liquidity provider is losing, then he doesn't want to be a liquidity provider anymore. So he's withdrawing liquidity from the pool. But if you withdraw liquidity from the pool, that means that you are left with a shallower pool, right? The depth of the pool goes down. If the depth of the pool goes down, that means that it becomes more costly to trade because the price impact is larger. So in a way, also the traders are losing and are not benefiting from the provision of liquidity. So we basically want to solve the problem at its root. We don't want the liquidity provider to be losing money and withdrawing, because this is impacting the long-term sustainability of the entire ecosystem. And one strategy, one way to do that is to basically avoid the risk that liquidity providers are picked off. And how can we do that? One possible mechanism to do that is the just-in-time liquidity approach, which is a new form of liquidity provision strategy, which is typically conducted on Uniswap V3. And I think Xin here has been one of the pioneers, together with Austin. I think we started on this, writing your white paper. And we're building a model which is essentially capturing whether or not this form of liquidity provision is beneficial or not. So let me explain what just-in-time liquidity means. Basically, the basic idea is that we take advantage of the fact that the order flow on public distributed ledger is publicly visible to everybody. So if you submit an order in the public pool, then everybody who is part of this the blockchain can observe the order. And as a result, what we can do, like as market makers, we can select which pending market orders are most beneficial to provide liquidity against. So I think what Andreas was mentioning at the end of the last talk is like we could have orders, like retail orders, which perhaps are uninformed and for which it's beneficial to provide liquidity, or maybe there might be other orders which are a little bit more toxic and then I don't want to provide liquidity. So I can decide as a liquidity provider how much liquidity I want to add or I want to provide to a swap order, so that I can make like the execution cost of the swap order lower, and in turn I can benefit from the fees that are paid by the swapper. So it's like called just in time because it's really done at the time where you observe the swap order. So in a way, it's like as if you provide the resources exactly at the times where they are needed. So you don't really wait there. You don't just provide liquidity at the very beginning and then wait for the swap to come. No, you first observe the swap and then you decide whether or not you want to provide liquidity. It's like, I think when we had a podcast with Xin on the just-in-time liquidity, I remember like we came up with the example of pizza delivery versus pizza shop. It's like providing the pizza when somebody's asking for the order, rather than maybe preparing the pizza in the very beginning and then waiting for somebody to come and buy the slice. And so that's the idea. It's a very simple idea. What is, in a way, it's an active form of market maker. You are actively monitoring the order flow and you are deciding whether or not and when to provide liquidity. And one advantage that you have as a liquidity provider, which is also called just-in-time liquidity provider in this talk, is the so-called second mover advantage. I think we have all heard about first mover advantage, but here the key is really the second mover, because you can pre-screen the market orders and you can mitigate the risk of being adversely selected. For example, you can compare the prices on Binance with the prices on DEXs, and then you can try to figure out whether or not this market order that has been submitted is informed or uninformed, and therefore you can decide whether or not you want to provide liquidity. So in a way, they resemble the high-frequency traders, like the fastest HFT. Typically, they pick up the most attractive orders, and they cancel very quickly ahead when they see toxic orders. And I mean, there's been a lot of discussion, a lot of literature showing that the entry of HFT can reduce adverse selection cost, and can increase trading, so it can be beneficial for the entire ecosystem. And it's important also for both retail and institutional investors. I think Andreas and Kadi have a paper on that. So one disadvantage of this is, I mean, one analogy that I think we found useful to understand the relation between this type of liquidity provision and what we see in traditional trading is the so-called cream skimming phenomenon, which basically is the fact that what can happen is that some traders like HFT can use advanced technology and algorithms to identify trades on the most profitable orders, and then they basically try to provide flow only to those orders which are uninformed. And this basically means that they are taking the cream of the milk, and then the bad part of the milk is going to these lower market participants, which are essentially left off with filling maybe orders which are toxic. So this is essentially a potential problem with just-in-time liquidity, in the sense that basically the slower liquidity provider will be left with all the adverse selection cost. So there is also, I think we can also relate it or understand how this connect with the payment for order flow. So in a way, like if you provide JIT liquidity for like orders submitted on the axis and publicly visible on the blockchain, this is like an order by order payment for order flow, in the sense that customers which are uninformed, they will basically be able to get better execution compared to those compared to the pool where we don't have this just-in-time liquidity provider because of the additional liquidity that is provided into the pool. So in a way, they are basically getting they are paying for the order flow, but they are getting better execution because we have more liquidity into the pool. Of course, the disadvantage is what I mentioned before, that the uninformed orders can basically be left or can be dumped on the passive liquidity providers in the pool. So these are the ones that are at risk of being adversely selected, and these are the ones who are not getting the cream of the milk. So the main question that we are answering in this paper is, first of all, whether or not just-in-time liquidity is beneficial for the entire market in terms of liquidity provision. So do we see like deeper pool? Does it enhance market liquidity? If that's the case, of course, it's great, because we all want, it immediately means that the market quality is going up. But if this is not the case, then we want to answer the question of what can we do to improve the system? What type of solutions we can think of, like for making the system better and still having the coexistence of just-in-time liquidity provider with passive liquidity providers. I mean, I will skip, but there is a lot of literature on this topic, ranging from like designing DEX. Just-in-time liquidity is a little bit more scarce. Like there is the paper of Xin and Austin, and like another follow-up paper that that has been written. And then I think it connects also to some literature on high-frequency trading and the payment for the flow and skimming along the lines that I had suggested in the previous slides. I think at this point, I will start with the model. It might be a good...
And if I'm, Agostino, if I may interrupt you here.
Yeah.
So you asked me to interrupt you actually at this point, right?
Perfect.
Just before you start with the model.
Yeah.
So just very briefly to you know, change the flow just a little bit. There are no questions in the Q&A. I will just make two observations here, just just to add to this. So forgetting about the crypto space for a moment, the idea of how actually to deal with uninformed order flow and how to deal with the different market structures that exist is actually a topic of very active and ongoing debate, even in the equity markets. So the SEC, for instance, put out a proposal for a new market structure in December of 2022. It is still up for debate. They essentially invented a new type of trading system in the process, because there's a significant number of people at the SEC and at regulators that hate payment for order flow, precisely because of the issue that it imposes possibly an externality on liquidity providers in the open market. And so I think this is a topic which is actually, I mean, it's very important for the crypto and blockchain space, but I think it's even bigger. And I'm just going to make the observation, because as somebody who's worked extensively on market structure, it looks like a dark pool, but in many ways it's worse. It creates worse information asymmetry problems, and it also looks like payment for order flow, but it actually looks worse, because payment for order flow, there's a deal that you have to take order flow, which could be potentially costly for you, and here you literally get to choose whatever works best for you. Just very simply, in the pool, you could see that there's two offsetting orders in there, and you can basically provide liquidity for those. These are essentially the orders that provide the fee income for liquidity providers in AMMs that sort of offset the adverse selection losses that you face when they're, as you say, right, the arbitrage losses that you face if the market price moves. And in this case, you can literally, eat up the fees of these liquidity providers in its entirety. This is it's fascinating that it's happening. I think this is probably going to be one of the biggest problems for widespread adoption that we will see in markets, for actually the adoption of automated markets and decentralized markets. And with that, because I think you have a lot to say on this, I'm going to hand over so you can present us our model, which helps us then better understand what the possible problems are. So.
Thank you so much, Andreas. I mean, these are like two great observations. I mean, definitely agree with both of them. Yeah, hopefully I think the issue is actually bigger than what we see just in the crypto space. Let me go ahead now with a brief discussion of the model, and then I will illustrate some results. So at this part, it will become a little bit more technical because I have to introduce the game theoretical model, but I'm trying to really give the gist of the paper, like I'm extracting away from the technicalities. So the idea is that we work with a general pricing function. As I mentioned at the very beginning, the pricing function, like the invariance constant product function for Uniswap, would be a special case of a more general convex pricing function, which we use. And the reason why we have a pricing function which is increasing and convex is because we want to capture the fact that the exchange rate, the swap exchange rate has to be positive, and also there must be some price impact which is captured by the convexity of this pricing function. So we have, let's say, two coins here. We are thinking of a risky coin and a stable coin that would be swapped, and the swap has to preserve this invariant level. So if you deposit some risky coin and you take out stable coins from the pool, the value of the function has to remain equal to the invariance level. And the fee are earned pro rata by the liquidity providers, so in proportion to the share of the pool that you hold. So that's like standard capturing the mechanics of the IMM pricing into the pools. We are going to set up a game theoretical model to precisely understand what are the incentives behind providing liquidity, behind trading, and therefore understanding whether or not these just-in-time liquidity providers are beneficial, so are complementing in a way the passive liquidity providers, or they are actually substituting them. The model works as follows. So there are 5 stages in this game. In the first stage, the passive liquidity providers are deciding whether or not they want to deposit. If they don't deposit, there will be a liquidity freeze. But if they deposit, then in the second stage, there are 2 possible outcomes. Either an informed trader comes and submits an order to trade. These are like the toxic orders. Or it could be that an uninformed trader arrives. Somebody wants to swap for purely allocation reasons. For example, they have to fill a margin call and they need to extract some Ethereum tokens from the pool. Then in the third period, the just-in-time liquidity provider is basically deciding whether or not they provide liquidity. So if they see that the trader is informed, then they will not deposit because they don't want to be picked off. If instead they see that there is an uninformed trader coming and providing liquidity, then they will decide to deposit. So when they deposit, basically they the mechanics of the swap is the following. First, they provide liquidity, then the swap is executed, so they earn the fees from the execution, and then they withdraw liquidity right away. So this is capturing the just-in-time mechanism. So you provide liquidity, and then withdraw liquidity right away. It's only when it's needed. And then in the fifth stage, this game, there will be a shock to the price. So if, for example, there was a news, the price will change to reflect the news. Otherwise, if the trade was only done for a purely allocation reason, so that it was an uninformed order, there will be a reverse trade to reverse the price back to where it was before the execution. So the first stage here, there are like the passive liquidity provider. There are N of them. They have an endowment of risky coin and stable coins. One of these coin is the numeraire, like the stable coin is the numeraire. And the idea is basically that this passive provider will decide how much of this endowment to deposit into the pool. So the sum of all the deposits will form the total passive liquidity provision that we have in the pool. In the second period, like as I mentioned, there could be an informed trader or an uninformed trader coming. So an uninformed trader, so if there is an informed trader, we're assuming that he has a perfectly predicted signal on the future price. So he knows for sure that the price will change in period 5. And he knows that it will, for example, go up or down. We could relax this assumption and say that instead of perfectly predictive, he has some like information which is correlated with the future price, but I don't think this will change much the insights of the study. And the assumption is that this trader will arrive with some probability alpha. So he's not arriving for sure. He has some probability alpha of coming. If he comes, then depending on what is the news that he has, he will either trade a risky coin for stable coin or vice versa, and then he will submit his order to the mempool. Or there could be, again, an uninformed trader who comes. So with probability 1 minus alpha, instead of being informed, the trader who comes is uninformed, and he has a private valuation for the coin. So we're assuming that he has a private valuation of the risky coin, which is decided with a model which says that with some probability he likes the stable coin more than the risky coin. So his valuation of the risky coin is P over this zeta U. And with some other probability, instead, he likes the risky coin. So his valuation of the risky coin is P, which is the fundamental price, times this zeta. So it's basically values the risky coin more or less with some probability. And as a result, depending on what is his valuation, he will decide to submit an order to swap the risky coin for the stable coin if he values more the risky coin, or vice versa. He will swap the risky coin for the stable coin if he values more the stable coin. And then he submits his order again to the pool. So the third period, we're assuming that there is a just-in-time liquidity provider. So just a monopolistic just-in-time liquidity provider is coming and is submitting, it's coming with some probability pi. So this pi is between 0 and 1. It's not clear. It's not guaranteed that it will be coming and provide liquidity. And then upon arrival, he will, if he sees that the order is uninformed, then he will submit an order of depositing risky coin and stable coins according to the price ratio determined by the pricing function. And then this deposit will be essentially sandwiching the trader swap. So he will first provide liquidity, then swap is executed, and then he will withdraw liquidity right after the swap has been executed. Like fourth period is just like mechanically the settlement of the trade. And then in the fifth period, we will see that depending on whether or not there was information, there was an information in the market or not, the price will either adjust to reflect the new price in case the trade was done by an informed trader, or if the order was submitted by an uninformed trader, then we are assuming that the price of the risky coin goes back to where it was before the trade. And the reason why it goes back is because an arbitrager can come and execute a reverse trade arbitrage. So who is capturing the benefit is not the liquidity provider, but is precisely the arbitrager. Okay, so that's the model. Now, I think I will go and discuss what are the main results that we get. So the first result that we get is basically we can write down an expression for the liquidity, for the utility function of the passive liquidity provider, which can be nicely interpreted as follows. You have basically that if you deposit a specific amount of token, DP, so that's the deposit expressed in the units of the stable coin, Then you have a risk of being adversely selected, which happens with probability alpha. And then you have some expected revenue coming from your liquidity, from the fees paid by the traders, which happens with probability 1 minus alpha, because depending on whether or not the informed trader or the uninformed trader comes, you either have the cost, so the first term is negative alpha C, or you have the benefit, which is this revenue per unit of liquidity provided. Then I think from this expression, you can see right away whether or not you have an incentive to deposit. When would you deposit? You deposit if your utility is positive, right? If your utility is negative, you don't want to deposit it because you would end up losing more from being adversely selecting relative to gaining from the fees. And therefore, in principle, there could be a liquidity free, passive, we call passive liquidity freeze, because the passive liquidity providers may stop depositing liquidity if they see that the adverse selection cost is too large compared to the fees that they're making. So then that basically means that there is an effect, which is the crowding. And essentially what we see is that what we're asking is the question of when does crowding here occur and when does complementing occur? So one of the main questions that we want to answer is whether or not the presence of the passive liquidity provider is benefiting or is hurting. So the presence of active liquidity provider or just-in-time liquidity provider is benefiting or making things worse for the passive liquidity provider. And we see that, I mean, we're saying that there is a crowding out effect or a substitution effect when the liquidity provider utility for the passive liquidity provider is going down when there is a just-in-time liquidity provider. So you compare the revenue per unit of liquidity provision when there is zero probability that a just-in-time liquidity provider comes, with the revenue per unit of liquidity provided when there is a probability pi that the just-in-time liquidity provider comes. So if the revenue when no liquidity provider comes is larger than the revenue when there is a probability pi of a just-in-time liquidity provider coming, then you say that the just-in-time liquidity provider is crowding out the passive liquidity provider, because the passive liquidity provider would be better off in terms of revenue when there is no just-in-time liquidity provider. The other regime is that instead the revenue of the passive liquidity provider, when this active provider is coming with probability pi, is actually larger. In this case, we are saying that the active liquidity provider, just-in-time provider, is complementing the passive liquidity provider. So we want to understand like whether or not we have crowding or complementing. And if we want to understand this even like in more intuitively, the idea is the following. So there could be a situation where there are only passive liquidity providers. Let's say 100% of the pool is covered by passive liquidity providers. So they are the only one who provide liquidity. Or we could end up in a situation where, let's say, a percentage of the pool is provided, percentage of liquidity in the pool is coming from passive liquidity provider, and the remaining percentage is coming from the active liquidity provider. And here we could have, let's say, two possible situations. The first situation is the complementing, in the sense that when, let's say, 70% of the pool liquidity is provided by active liquidity provider, this means that these are also making 70% of the total fees that are paid to the pool. Whereas the passive liquidity provider only getting 30%. So they are going from 100% of the fees captured by them to only 30% of the fees captured. But what could happen is that because there is more liquidity in the pool, there might be more trading going on because the price impact is lower, right? So there might be a higher incentive for traders to trade. As a result, the total pie might become larger. So you are basically getting a smaller share of a bigger pie. And maybe in total, if you get a smaller share of a bigger pie, you may end up eating more than when you were getting the entire share of a smaller pie. The other situation instead is the so-called substitution regime, which happens when somewhat the passive provider are getting a smaller share of the pool, but also the total share of the pool is not, the total pool is not becoming bigger, it's actually becoming smaller. So it's not smaller, it's growing, but not by much. So in this case, you are getting a smaller share of a slightly bigger pie, and you might be better off like when you were getting the entire pie. So that's the idea. So the basic point is this just-in-time liquidity is introducing or is causing an extra order flow demand, but at the same time, it's also diluting the share of the passive liquidity provider. And this trade-off is key to understand whether or not we have crowding or whether or not we have complementing. And essentially what we find is that the just-in-time liquidity provider is complementing the passive liquidity provider, if and only if this, this quantity, which we call zeta u, which is essentially capturing the value of trading for the order flow investors. So if they have a high sensitivity to the pool liquidity, so if basically they want to trade much more when the liquidity of the pool goes up because they have strong incentives to trade, like then we see that the pie is getting bigger, and as a result, we are in a complementing regime. So if this threshold zeta u, which means now exactly the order flow demand, is sufficiently large, then we are in the complementing regime. Otherwise, we are in the crowding regime. And what is concerning is that if we have a passive liquidity freeze, this can lead to a full liquidity freeze. So one could ask the question, okay, suppose that there is no passive liquidity at all in the pool. So the pool is completely empty. Would traders submit market orders? Would they be willing to trade? And then one could argue, okay, perhaps they might still decide to trade because they can anticipate that just-in-time liquidity providers will be filling their order. So at the moment, there is no liquidity in the pool, but I anticipate that after submitting my order, there will be a lot of JIT providers who are trading against me. But I think the answer to this question is actually no, because without the passive liquidity providers, what happens is that if the just-in-time liquidity provider are submitting liquidity, they will be earning the entire share of the fees because there are 100% of just-in-time liquidity providers only. So if they are already earning the full share of the fees, they are already getting the entire pie, they also have an incentive to provide very minimal liquidity because they also want to earn from the price impact, right? If they provide a lot of liquidity, they are always getting this 100% share of the fees, but also they are reducing the price impact, right, of the trade. And the just-in-time liquidity provider wants to actually earn from the price impact. So that's the reason why, there is no, in a way, if nobody's providing liquidity at the very beginning, if there is no passive provision, there will be no liquidity at all in the pool. Okay, so now the last part of the talk, I want to discuss a bit on how we can incentivize passive liquidity providers to deposit. We have seen up to now that there could be essentially a situation where the liquidity provider, the passive liquidity providers, might be crowded out by the active liquidity providers. So how can we avoid this? Like, how can we mitigate this effect? So we would like to see complementing. We don't want to see crowding. And the question is, how can we reduce the likelihood that there is a crowding event or there is a crowding effect? And we are looking at two possible ways of doing this. One is introducing a two-tier fee system. Instead of each liquidity provider getting a fee which is corresponding to its pro rata share of the pool, we want to provide, we propose a slight modification of the system, which incentivizes more passive liquidity provision and disincentivize just-in-time liquidity provision when it's not needed. And the second is like we are analyzing also what would happen if there is competition among just-in-time liquidity providers and showing whether or verifying whether more competition between JIT providers actually could reduce these crowding effects. So let's look at the first strategies to just provide. Let's assume that we introduce a two-tier fee structure. So this means that part of the revenues now of the just-in-time liquidity providers are transferred to the passive liquidity providers. So let's say we pick a parameter lambda, which is a percentage of the fees that are retained by the just-in-time liquidity provider. So if lambda is equal to 0, it means that all the fees of the just-in-time liquidity provider are entirely transferred to the passive liquidity provider. If lambda is equal to 1, instead, we are basically in the current situation where just-in-time liquidity provider, they capture the entire pro rata share of their fees. So we can play with this parameter lambda and essentially see what happens in terms of incentives to provide liquidity when we make lambda smaller and smaller. So if we go to 0, it means that we don't give any fee to the just-in-time liquidity provider. So what we find is that, okay, if we look at the equilibrium response of all the agents to a decrease in lambda, we see that reducing lambda is reducing the deposit of just-in-time liquidity provider compared to those of the passive liquidity providers, which is a bit expected and intuitive, right? Because you are somewhat disincentivize them from providing liquidity because all what they carry is the fees, but you're reducing their fees. And it's also increasing the overall utility of the passive liquidity providers, which means that the revenue per unit of liquidity provided is always decreasing if lambda increases. So in a way, if lambda goes down, then they are making more revenue from fees. So this means that, I mean, then the question is, what is somewhat the optimal fee design? Because we don't want to essentially, I mean, we want to incentivize passive liquidity providers to deposit, because otherwise there would be a liquidity freeze and there is no benefit from trading. But on the other hand, we also don't want to put an excessive burden on just-in-time liquidity provider, because we also want them to top up the liquidity. We want them to complement the liquidity in the pool. And I mean, and then basically what we can show is that there is an optimal fee transfer that maximizes the gains from trades. So if we look at some of the welfare cap, which is captured by the gains from trading, we see that this is maximized at a value which is neither 0 nor 1. So there is something in between. And in a way, if we want to relate this to what happens in traditional market microstructure, I mean, one analogy that we find is that this is like similar to the tier fee in centralized exchange, where you have designated market makers that get some benefit providing that they always quote. So this could be the passive liquidity providers. They're always there and they get some benefit in terms of rebates or reduced fees when they trade. So, I mean, one could think about, I mean, this is something that maybe Uniswap X, Uniswap may want to consider, like how can a solution like this be implemented? I think one simple way that we thought of how to make this implementable is to think about following. Suppose that we ask each liquidity provider at the moment where they provide liquidity, they have to specify whether or not they will be there long-term or short-term. And suppose that long-term means that they will stay there for at least one block. So they are not withdrawing the liquidity right away after the trade. Or if they are short-term liquidity providers or just-in-time liquidity providers, they specify this variable to be equal to 0. That means that they will withdraw right away. And then I think if this variable, once this variable is specified, is kept tracked by the smart contract, and as a result, liquidity providers will not be able to withdraw if they have specified that their phi is equal to 1, right? Because they have to stay there for at least one block. I mean, one block is just arbitrary. It could be 2 blocks. I mean, just don't have to withdraw liquidity right away. And then like the smart contract can also keep track of 2 global fee variables, like one corresponding to the fees that will be earned by the active liquidity providers, and the other one corresponds to the fee that are earned by the passive liquidity provider. And they can specify also as a parameter the lambda, the percentage of transfer that goes from active to passive. And at the time where the swap is executed, when the fees are paid, then the smart contract could pay the short-term liquidity provider with their fees plus a lambda portion that was accruing to the active providers, because now this is deposited to the account of the short-term liquidity provider. And the remaining 1 minus lambda instead is transferred to the account of the long-term liquidity provider. So every time there is a trade, they're essentially keeping track of these variables and updating them. I mean, that seems to be a solution. I mean, I'm be happy to hear what Xin thinks about it, and I mean, what you all think about that. The other way that we found to be good for incentivize for reducing the crowding effect is to have a competitive just-in-time liquidity provider sector. So here we have looked at an extension of the model where instead of having a monopolistic liquidity provider, we have 2 just-in-time liquidity providers just to introduce some competition. They will basically all come with some probability. Let's say the probability is the same, but their arrival are independent. So with probability pi, one counts, with probability pi also the other counts. These arrival are independent. And let's say also that each just-in-time provider has a perfect signal about the arrival of its competitor. Now, what happens is that in this case, we can redo all the analysis, and we can still find that there is a threshold beyond which the just-in-time liquidity providers are complementing the passive liquidity provider. So as we said before, like if some of the the value of trading, which pins down the order flow demand, is sufficiently large compared to this threshold, which now depends on the fact that there is competition, then we will see complementing, otherwise we will see crowding. So crowding can still happen, even if we have a competitive liquidity provider sector. But what is nice is that the threshold beyond which there is crowding is now smaller than the threshold, beyond which there is complementing is now smaller than the threshold when there was complementing, when we had a monopolistic just-in-time liquidity provider sector. So that means that complementing will happen for a larger range of the parameter space, right? Because it's like enough for the order flow demand sensitivity to be larger than this size star C to observe complementing. So if we want to visualize this with a graph, I think here we are plotting basically the region under which you observe competition, under which you observe like crowding under a monopolistic liquidity provider, just-in-time liquidity provider market, and the competitive just-in-time liquidity provider market. And what you see here plotted is the threshold beyond which there is complementing. So as you can see, when we have a competitive liquidity provider, just-in-time liquidity provider market, you see that complementing will happen for a like larger range of the market space. So this entire gray area is basically the region under which you have complementing when there are two just-in-time liquidity provider, and you instead have crowding when you have only one just-in-time liquidity provider, because the threshold to have complementing when you have one just-in-time liquidity provider is this blue line. So in a way, the takeaway from this is that having more competition in the just-in-time liquidity provider market is actually beneficial in terms of reducing crowding and encouraging for coexistence of passive and active liquidity provision. Okay, basic idea, like if one wants to look at the intuition, why competition benefits passive provider is because if you have, let's say, just-in-time liquidity provider who are competing a la Cournot, so in terms of the quantity that are deposited to the pool, they basically will end up forming a deeper pool because they both want to capture a share of the liquidity pool, so they care about having like a significant share of the fees that are paid. So that means that the deeper pool is leading to higher trading, because now uninformed traders see that there is a deeper pool, so they will have a higher incentive to trade because they pay a smaller price impact. But then if there is more trading volume, that means that there are also more fees that will be earned by the passive liquidity provider. And this is precisely why crowding becomes less likely to happen, right? Because there is more fees to be earned by the passive liquidity providers. Okay, so I think this is the last slide, which I originally thought that this would be the slide of connecting my presentation to Xin presentation, but I think it's also good to have it at the very end because it summarizes like why we had this webinar connect with just-in-time and Uniswap X. I think there are some similarity and differences. I think as Xin also mentioned in his presentation, like through Uniswap X, we have these fielders who are essentially, one way we can think about these fielders are essentially just-in-time liquidity providers, but operating off-chain instead of operating on-chain. And I think one of the benefits that Xin also mentioned is that the benefit of being off-chain versus on-chain is that you will not have to worry about front-running and sandwich attacks, like when you fill the orders, because these orders are not private, are only privately visible, but not publicly visible to everybody. I think one of the some of the differences that I see, we all see between just-in-time liquidity provider and Uniswap X, which operates with this RFQ system, is that I think in Uniswap X, at least at the moment, the filler have to fill the entire order, right? There is no possibility of partial filling. Like it's only either you fully fill the order or you don't. And it's all, I mean, the execution is also to fill this order outside of the pool, which basically results in more fragmentation. And also like filling an entire order might be capital intensive, right? Because you might have to source a lot of liquidity, as you are mentioning in your presentation, like you might have maybe dedicated pools where you can go and source liquidity from. And maybe some market makers might be more happy to fill this order partially. So I think these are like nice, so there are some difference in terms of infrastructure and also in terms of current design. which might be worth exploring more. And with this, I think I want to conclude. The basic point here is to, first of all, present what just-in-time liquidity provision is, and also understand this at first paradoxical statement that if you have, in principle, more strategy to provide liquidity, you may end up with less liquidity provided in the pool, precisely because this crowding effect might lead to a liquidity freeze where passively providers don't deposit, and as a result, nobody will deposit. And two possible ways of reducing this problem or mitigating this problem of crowding is, first, one would be to have different differentiated fee structure for just-in-time and passive liquidity providers, so that we can go more towards the complementing regime. And another way, I think, is to promote more competition in the JIT market, because they will basically compete with each other and they will benefit the passive liquidity providers with more trading fees being deposited to the pool. Yeah, and that's
thank you so much, Agostino. So there was a fairly active session in the Q&A. I didn't want to interrupt you in making your main points, because I figured that some of the things you would implicitly and explicitly address. But I think I want to go back to some of the things in case the audience has missed it. So Olga made a number of important observations, but also Sean Foley and Jigo Hey. And then let me add a little bit to this. So I am absolutely incredulous about this. So as you know, I've written some work on the possibility of front running in AMMs. This is actually this is significantly worse. And I'm going to just very briefly outline what the problem is here. So essentially you see orders come for an AMM. Let's say the AMM is reasonably active. What you could do is, if you're working on the, let's say on the back end, and you have the ability as being an MEV extractor. Now I know you have the competition part here, but imagine you are the block builder and you actually can do the MEV extraction. What you would do is as follows. You take all of the orders that come in and that are balanced. So where buys and sells of a particular token just add up to 0, okay? Then you take a flash loan out, you put an enormous amount of liquidity into the contract just before you would process the balanced order flow. You would capture, I mean, if you take this in the limit, you put an infinite amount of liquidity in, so you crowd out entirely the existing liquidity in the pool. You get all of the fees, and then you withdraw your liquidity precisely after all of the balanced orders. So now this goes, Olga makes the observation that when you have larger block times, you see more just-in-time liquidity than in shorter ones. I think, this is one reason why you should do it, because you should see a more balanced order flow over any period of time where you can actually provide this operation. If somebody will figure this out at some point and will actually do this, and liquidity providers will only get the toxic order flow. So as before, I think, for all of the blockchain world, getting a handle on whatever happens under the underbelly, which is basically operated where the MEV extraction is like first order of importance, because you can forget about the entire market at some point with this, right? So now Olga made another observation here, basically was about the block time. Zigo He basically said the same thing, is like, if you're informed order flow, a JIT provider, that makes a difference. So as I just described it to you, you're informed in the sense of automatically, because you can see whatever order flow is balanced. So you can pick out the balanced order flow. And then Sean makes the observation that this is just like a dark pool, or similar to a dark pool, where I would actually add that this is worse than a dark pool, because in a dark pool, you actually have to put your liquidity in. You don't get to pick and choose. You get to pick and choose. This is a disaster, honestly. This is a disaster in the making. But maybe somebody else has an opinion on this one. I know that I'm done with my rant here. So maybe, so are there maybe any questions from the audience? So maybe some hands up here. We're almost at the end, but I think there's been a fair bit of comments in the chat. Oh, and I see. I would just want to point Jin on the spot here, but I think Jin, you have to leave in a second. Do you want to maybe respond quickly to my little rant?
No, I mean, I think what you said is definitely a big concern here as well, and it's something that we're trying to avoid. But again, it's kind of the final equilibrium. We know that we have some hopefully some time before we get there, and hopefully, you know, the innovation in the DEX and blockchain space catches up quick enough to before we get there. But I do want to say, you know, thanks a lot for having me on the platform today. I do need to go to a meeting, but I'm happy to share my email, which is just my first name, xin@uniswap.org, not .com. So if you're interested, feel free to just send me an email and we can chat offline. So with that, I will have to go to another meeting, but thanks again for having me, and thanks everyone for coming.
Well, thanks so much, Jin, and also thanks so much for your presentation, Agostino. It was very insightful, and I think you tackled a very important problem there, and you made a very good way for us to understand what the problems are that are arisen. All right, so since there's no hands up, and I've seen already half the audience has left, I think we should close the webinar. Thanks, everybody, and this talk, as any other, will be available on YouTube soon. And thanks for Fahad for organizing and doing the logistics in the background.